Hello guys, welcome to another video. This is completely theoretical video and I would like to discuss what are all the optimization techniques which Databricks applies by default either on the tables while querying or on the notebook commands which we run. First one is predictive optimization for data lake. Here in this technique, Databricks will automatically detect which tables requires the maintenance and it runs the optimize command or the vacuum command and all. The optimize command, what does optimize command does? It does the liquid clustering. What does liquid clustering means? Like based on the select statements we run on a table, the data underneath will be reordered based on the queries we run automatically. So that reordering is called liquid clustering. And the second technique is vacuum. Like suppose the data is deleted, and once the data is deleted, we don't immediately delete the data files underneath, we just mark them as deleted. So removing those kind of files which are not being read recently, we can control that using the retention period as well. This is the command which we can increase the retention period. So these kind of things comes under predictive optimization for delta lake tables. And the next technique is disk catching. In Spark we have catching technique, catching and persist, right? Similarly in Spark we do catchy and persist only when we would like to do. We have to manually do that operation, dot catchy, dot persist and all. It depends whether we do in memory or disk. Mostly we do in memory. Here in disk catching, whenever you read the table will be catched in the disk in our cluster, so that the subsequent reads will be very fast, which will be read directly from the disk itself. That's the second optimization techniques. The next technique is Photon accelerated updated. Like in Databricks, we can enable the Photon enable cluster. Once you enable the Photon on your cluster, so the delete, merge and update operations works much better than normal operations. Like what is the advantage with the Photon enable cluster is, for suppose if your record is updated, normally in Spark, if a record is updated in a file underneath, it has to rewrite the whole file. Instead of rewriting the whole file, it creates a small supplement data files and writes the new updated data into those files and updates the transaction log, so that whenever you query the data, it first goes to the transaction log in the delta. The delta table follows the transaction log approach. So when you read the table, it goes to the transaction log. So it, instead of reading so and so updated data from the big data file, it goes and reads from the small subsequent supplement data file, so that the operation will be fast and we can avoid rewriting for every update. That's one thing. And even for deletes also, when you have the Photon enabled cluster, you don't have to delete the data file immediately when the delete operation is applied. Instead, you can mark those records which you want to delete as deleted, so that the transaction log is updated accordingly. And when you query the table, it won't read the records which are marked as deleted. That's the usefulness for Photon enabled cluster. And the second is Delta archival support. That means nothing but all, like in Azure or in AWS, the underneath storage for our data files is the cloud blob storage. So there will be a life cycle for each and every cloud. So our Databricks supports the life cycle of the cloud storage, so that after the life cycle is done, Databricks will not read the archived files. Which means, for suppose if you have a feature like where you archive the files every 30 days, our Databricks will not read those archived files, because they are archived by our cloud storage. That is called Delta archival support. And the next technique is dynamic file pruning. The dynamic file pruning works better when you have the Photon enabled cluster and when you try to read a unpartitioned table. Instead of reading the whole partition, it helps to read only the required set of files or the data alone. That is called dynamic file pruning. And the next is a low shuffle merge. In the low shuffle merge, this works for the merge statement. When you apply a merge statement, I like to update records and insert together, we use merge in Databricks, merge command. And we have the merge command even with Python and merge command in SQL as well. So when you apply the merge command, so our Databricks will handle unmodified rows separately and modified rows separately. so that we can avoid shuffling when we don't touch unmodified rows. That's called low shuffle merge. The next is adaptive query execution, and in Spark we know that when you run the code, the execution plan gets created. So when you have the adaptive query execution enabled, which means that the execution plan changes based on the runtime statistics. For suppose it decides initially to go with the sort merge join, but based on the runtime statistics it changes it with the broadcast hash join. For suppose if it has a small table and the larger table join, so instead of going with the sort merge join, it goes with the broadcast join. So that kind of dynamically changing of the execution plan is called adaptive query execution. And the next technique is called predictive input output. In this technique, it uses the deep learning techniques to decide which data blocks to read next. And the next one is called cost based optimizer. And in this cost based optimizer, with this cost based optimizer, if you see the picture here, it says like rows output estimated, I mean the 1000x. Here it estimated saying we have to read so and so rows, but the actual rows we read is to so and so, which is a lesser number. Actual rows we read, but the estimation is higher. That means it in pre-year decides how many rows we are going to read. With that, we'll have the advantage to change the execution plan accordingly. So to enable this, we need to have our statistics for the table and the columns are updated and up to date. And to get the statistics of our table and columns, we use the analyze command. And the next one is Bloom filter index. Using this Bloom filter index technique, we can skip reading some files. We know like underneath the data is stored in the files, and when you create Bloom filter index and so columns, we can skip reading so and so files, so that the overall data scan will be lesser and the read operation will be quicker. And in the last technique is called deletion vectors. And we know like when you apply delete operation on a table, instead of deleting that record and rewriting the whole partition, we can just mark those rows alone or the records alone as deleted. And so when you apply the vacuum command, the actual deletion can happen. But because of this deletion vectors, we'll just mark the records alone as deleted and update the transaction log, so that when you query immediately the same delta table, it goes to the transaction log first and it finds out that the so and so records are deleted, so it won't read those, it won't return those rows. So these are the techniques which Databricks by default follows, and which we don't have to explicitly mention. Like previously, when you have the Spark jobs, when you run the Spark jobs on the big clusters, we have to do all this kind of optimization techniques. Now we don't have to have all those headaches, and we can just concentrate on the development purpose alone. The optimizations and everything are underneath taken care by the Databricks and using the Databricks runtime. That's it. Thank you so much, guys.